infinity if n is odd, minus infinity if n is odd, and plus infinity if n is even. Plus infinity if n is even. Therefore, what is this? Limit value is what? Limit may be finite or infinite. Remember, limit exists means what? Limit value may be finite or infinite. Here, limit is infinite. Limit is infinite but not unique. Limit is infinite but not unique. Same logic. Let us take one infinity limit but unique. Simple example, one can take n square. That is limit an as n tends to infinity what? Limit n square as n tends to infinity. Limit is infinity and a unique only. Unique only. Similarly, you can take 1 by some 2n plus 1. 1 by 2n plus 1. Or one can take, El Hospital rule or something in intermediate, right? If I write this as some n by 2n square plus 1. N by 2n square plus 1. What is the limit value then? The limit n tends to infinity. N by 2n square plus 1. This is limit n tends to infinity. Somebody open your audio. Please close that. Equal to. You take n common, right? Limit n tends to infinity. N common in numerator and denominator. So there will be one n here. 2 plus 1 by n square. Anyway, something by n is there. So this value 0. This is finite and unique. Finite and unique. So limit value, the question is, the answer is limit exist means limit may exist finitely and uniquely. Limit may exist infinite, uniquely. Limit exists but not uniquely. Limit exists infinitely but not uniquely. These are the cases for the limit. Okay, this is the concept of limit, and you know how to evaluate this limit n tends to infinity. Okay, some typical function is there. One can use left limit, right limit definitions. If both are equal, then only limit exists. Those are all the concepts at intermediate level. Okay, now coming to after this limit concept, the behavior, the properties of sequence. Properties of sequence. The first property is convergent sequence. Convergent sequence. First property is convergent sequence. Okay, let me explain again from the beginning because the audio was not recorded startingly. See, once again, I'm explaining. Limit of a sequence means, first one, limit of a sequence. The sequence an is said to possess a limit L if for every epsilon greater than 0, epsilon is very, very small positive value, there exists one natural number n such that what is the meaning? The difference between an and L, this is nothing but the difference, the absolute value mod, the difference between an and L is very, very small after some particular terms in the sequence. So this definition simply written as limit an as n tends to infinity equal to L. And the first example, 1 over n, the example, obviously, if I take up directly apply this limit definition, you will get limit n tends to infinity 1 by n as 0. That is the value of L, finite and unique. Now, how to explain this definition? Modulus of an minus L less than epsilon. Considering 1 by 1 term, let us raise this n value from 1 onwards. A1, L value, what is that? As per the definition, if I apply definition, I will get 0. So L equals 0, A1 minus 0, and I'm taking epsilon as 10 power minus 3. Epsilon as 10 power minus 3. So this 1 minus 0, 1 is less than 10 power minus 3 is false. Therefore, this n cannot be 1. Next, if I take 10, A10 minus 0. So 1 by 10, that is 0.1 is not less than 10 power minus 3. So n value is not 10 also. If I take 1000th term, that is 1 by 1000, that is 10 power minus 3 is less than 10 power minus 3 is also false statement. Then when I take 101th term, then 1 by 101 is definitely less than 10 power minus 3. It is true. Similarly, a 1002 term, a 1 lakh term, a 1 crore term, every term after 1000. Every term after 1000 is definitely less than my prescribed epsilon 10 power minus 3. Therefore, the definition an minus L less than epsilon is true for n greater than or equal to 1000 not 1. This is the explanation for the theoretical definition. And the symbolic notation, this is limit n tends to infinity 1 by n equal to 0. Now, same case, if I consider instead of 10 power minus 3, if I consider 10 power minus 2, then obviously, as per the previous definition, this definition 1 by n minus 0 holds true for what? N greater than or equal to 101 term onwards. 101 term onwards. Now, if there is a question, define the limit of a sequence. Now, you remember this limit n tends to infinity an minus L, an equal to L in mind. Then how to write? See, the L is called limit of the sequence an if difference between these two, that is mod an minus L, difference between these two is very small, that's it. For what? For n greater than or equal to, this is infinity means some number, n greater than or equal to n. So just by remembering this, you can create this definition also. This is one idea. And is limit is unique? Limit may not be unique. Examples are this: minus 1 whole power n. Limit is either plus 1 or minus 1, therefore finite but not unique. In this example, limit is plus infinity or minus infinity, not finite, not unique. And another example, n square, limit is infinite and unique. Another example, this limit is 0, finite and unique. Now, based upon the value of the limit, that means finite, infinite, not finite, not unique, there are some properties, the properties of the sequence. First one, convergent sequence. Convergent sequence. The definition: a sequence an is said to be convergent. You know what is the meaning of convergent? General definition: convergent means going to some particular value, moving towards a particular value. A sequence an is said to be convergent if limit an equal to L, limit value of an as n tends to infinity L is finite and unique. Finite and unique. That means the cell value must be finite and unique. Therefore, the sequence an, simple example, 1 by n square is convergent. Why? Because limit an as n tends to infinity is what? Limit of 1 by n square, that is value 0. Limit n tends to infinity 1 by n square, 0 is finite and unique. Therefore, this sequence is convergent sequence. The next one is divergent sequence. I will write sequence SEQ, divergent sequence. A sequence an is said to be divergent. Diverge. Okay, diverge means spreading, not to unique point. Divergent if limit n tends to infinity an equal to either plus infinity or minus infinity. Remember, not both, either plus infinity or minus infinity. This R is very important. Plus infinity or minus infinity. Example, an is equal to something, n square plus 1. Therefore, what is limit an as n tends to infinity? Limit n tends to infinity n square plus 1. That is value infinity. Only plus infinity. Okay, you can create some example with minus infinity. Therefore, what is this sequence? Is divergent sequence. Since is divergent sequence. And the next one is oscillate sequence. Oscillate sequence. What is the oscillate sequence? In this one, there are first point. A sequence an oscillates finitely, oscillates finitely if limit n tends to infinity an is equal to is not unique and has finite value, not unique and has finite values, has finite values. Example, you know, what is this? An equal to minus 1 whole to the power of n, minus 1 whole to the power of n. What is this? Limit an as n tends to infinity. What is this? Is having two values, minus 1 and plus 1. If n is odd, minus 1. If n is even, plus 1. So an is oscillates finitely, oscillates finitely. Now oscillates infinitely, second one. Sequence an oscillates finitely, oscillates infinitely, oscillates infinitely if limit of the sequence is not finite and not unique, not finite and not unique. Example, not finite and not unique. That means an equal to, what is that? Minus 1 whole to the power of n into n. Okay, if I consider the limit of the sequence, limit an as n tends to infinity is equal to limit minus 1 whole to the power of n into n. So this value is what? This is minus infinity if n odd, and if n is odd, and plus infinity if n is even, n is even. Okay, therefore the sequence what? Oscillates infinitely, oscillates infinitely. This is the these are the properties. One is convergent property, convergent sequence, limit value must be unique and finite. Divergent sequence means limit value is either plus infinity or minus infinity. Infinite, simply infinite and unique. Oscillate sequence means oscillates finitely, limit is not unique and finite. Oscillates infinitely means limit is not finite, not unique. These are the properties of sequence. Any doubts? Yes, any doubts? Okay, let us consider one example. Examine.
Sir, can you explain the oscillating
sequence
again?
Yeah, okay. Oscillate
Yes.
sequence means what? The sequence an, there are two cases, oscillates finitely and infinitely. Oscillate means what? As per the definition of limit, limit value is not unique, then sequence is said to be oscillates. Is that clear? Limit value is not unique, then sequence is said to be oscillates. When limit value is not unique and having finite values, that means this minus 1 whole power n means limit value is what? Minus 1 when n is odd, plus 1 when n is even. That means this limit is having both values, minus 1 and plus 1, means it is oscillating between finite values, minus 1 and plus 1. This is oscillate finitely, not unique and has finite values. Okay, next one, oscillates infinitely means not finite, not unique. There is no finite value, infinite values, and those infinite values also not unique, means plus infinity and minus infinity. Oscillates between minus infinity and plus infinity, this sequence. Is that clear? Okay, let me take let me consider this example. an equal to 3 plus minus 1 whole power n, 3 plus minus 1 whole power n. To check this whether it is convergent sequence or divergent or oscillates, if I apply limit for the nth term, 3 plus minus 1 whole power n, right? So what is this? Since minus 1 whole power n is having two values, -1 when n is passing through odd values and +1 when n is passing through even values. Okay, so what is this value becomes? This is one can write, this is 3 minus 1 if n is odd, isn't it? And this is value 3 plus 1 if n is even. N is even. Therefore, what is the value of this limit value? Limit an as n tends to infinity. How many values? This is 2 and 4 if n is odd. And here if n is even. So what is the limit value? It is finite but not unique. Okay. So I'm writing limit is finite but not unique. But not unique. So oscillates, therefore finitely. Therefore sequence an oscillates finitely. Oscillates finitely. This is one example. Okay, I think it is clear. You solve some more problems. Just I'm giving some two test problems. Test the convergence of the sequence, where first problem an equal to n plus -1 whole power n, this power -1. This is first sequence. Second one example, an is equal to 1 plus -1 whole power n by n. And the third example, an equal to, simple problems, these are very simple problems. And anyway, the sequence is basic. Sequence is basic. You will get only one short question in this sequence. Okay, these are the three problems. Just solve them. And the next concept is series. Next concept is series. What is the definition of series? In intermediate, Taylor series is there? Yes?
No, sir.
The topic Taylor series is there in intermediate level?
No, sir.
No, sir.
No, sir.
No, sir.
No. Okay,
Yes,
can
sir.
you tell expansion of sin x? No. Can you tell expansion of sin x? Anyone? Expansion of sin x.
X minus x cubed by 3 factorial plus x power 5 by 5 factorial.
What is your name?
So, Nagakshita, sir.
Nagakshita, how you will get this series?
No, sir. We were taught in the chapter limits, sir.
No. You
I
don't know how the
how.
series is.
No, sir.
Yes, sir. This will be obtained from Taylor series, sir. And every expansion is from Taylor series.
Yes,
Once
exactly.
our sir had taught us.
Yeah, what is the use of this Taylor series?
To find expansion of x2.
In limits, if we can't integrate it, we can use this expansion.
Yes.
Yeah, see, what is the meaning of actually the series or e power x expansion? What is that? 1 plus x square by factorial 2 and so on, right? All these expansions are there. See, what is the observation here? This is trigonometric function, exponential function. I can consider log also, right? Log 1 plus x, log 1 minus x, cosine x expansion, tan x expansion, and tan inverse x expansion, sine inverse x expansion. All these are in terms of x. Say this one. What are these? Polynomials, right? Okay. So the functions, the trigonometric, exponential, logarithmic, these are all called transcendental functions. These are all called transcendental functions. Expressing transcendental functions in a series of polynomials. That is the beauty of Taylor series. That is the beauty of Taylor series. Sin x, I know the expansion in terms of x, e power x in terms of x, log in terms of x, right? That means any transcendental function can be expressed in terms of a series of x. Okay, now this is a series. This is a series. So definition of a series is what? If an is a sequence, if an is a sequence, then a1, sum of the terms of the sequence, okay, plus and so on, is called series. Just take the summation of the terms of the series in the terms of the sequence, that is called series expansion. Here we denote series as one can write sigma an. N is from 1 to infinity. What is that? First term a1 plus a2 and so on, plus an and so on. This is the notation for this series. Now onwards, I will write just summation an. Summation an means over summation, n is always start with 1, 1, 2, 3, and so on onwards. Okay, here this an is called nth term of the series. An is called nth term of the series. Nth term of the series, and this plays very an important role in behavior of a series. And see the properties, and this is called, in the sense there are infinite number of terms in the series, that is called infinite series. This is called sigma an. N is 1 to infinity is called an infinite series. An infinite series. And see what? See now the series depends on what? Series depends on what? The terms of the sequence, correct? The terms of the sequence. Taking the summation of the terms of the sequence, we are getting an infinite series. So the properties of sequence or the properties of series depends on properties of sequence. Once again, since series is obtained from the sequence terms of the sequence, the properties of series definitely depends on the properties of sequence. Let us see how it behaves. First one, the convergence of a sequence, or let me write directly: convergence, divergence, divergence, and oscillation, of a series. Okay, first one, convergent. And before going to this convergent, let me define one property: nth partial sum. Nth partial sum. What is meant by nth partial sum? Let an be a sequence. What I am considering? Sequence. An be a sequence, and sigma an be an infinite series. An infinite series. Then the sum of first n terms. The sum of the first n terms in the sequence. Or or directly you can write directly in series. The sum of first n terms in the series is called nth partial sum. That is sigma an equal to what? A1 plus A2 plus and so on, plus an plus n plus 1th term and so on. Infinite series. Then nth partial sum is denoted by Sn. Nth partial sum is denoted by Sn, means Sn equal to A1 plus A2, first sum of first n terms. A1 plus A2 up to An is called nth partial sum of the series. Now, I think this is clear. Let me explain. First property, convergent series. convergent series. A series sigma an is said to be convergent if the sequence, see the terminology, if the sequence of nth partial sum, a series an is said to be convergent if the sequence of nth partial sum is convergent. See, let me explain this. What is Sn? Okay, let me write just explanation. What is S1? S1 means sum of first term, that is A1. What is S2? Sum of first two terms. What is S3? Sum of first three terms. And so on. What is Sn? Sum of first n terms. Now, observe this. S1, S2, S3, S4, Sn, that is, what is this one? S1, S2, S3, and so on, is what is the sequence of nth partial sums. First partial sum, second partial sum, third partial sum, and so on. Okay, this is 1, 2, first term, second term, third term. So third term of what are these terms? Partial sums. Therefore, this is named as sequence of nth partial sums. Now, what is this one? What is this? Series is said to be convergent when sequence of nth partial sum is convergent. Means what? That is, therefore, I will write sequence of n like this. This is what? Sequence of nth partial sum. And when it comes, since it is a sequence, when a sequence is convergent, when its limit value is finite as n tends to infinity. Therefore, if Sn is convergent, then the series, what is the series? Corresponding series, sigma an also convergent. That is, what is the meaning? When sequence is convergent, limit of Sn is L. What is this L? Finite. And what it must be? Unique for convergent. Finite and unique, then sigma an is convergent. Remember this. Is the property, first property, convergent of a series. When a sequence of nth partial sum is convergent, then series is also convergent. Okay, this is the first one. And next, divergent sequence. Divergent series, not sequence, divergent series. If, write like this, if the sequence of nth partial sum is divergent, then the corresponding series, sigma an also divergent. So what is the meaning of this in mathematically? That is, if limit Sn means sum of first n terms, is equal to what? Either plus infinity or what? Minus infinity, then sigma an is divergent. So you remember this, sigma an is divergent. And next one, Obviously, what is the another one? Oscillate sequence. Oscillate sequence. Sorry, series. Oscillate series. Similarly, here oscillate series, there are two ways. Oscillates finitely, oscillates infinitely. So directly I'm giving, what is that? If the sequence Sn of nth partial sums is oscillates, then the series sigma an also oscillates. That is what? Limit Sn as n tends to infinity. There are two cases. One is what? Oscillates finitely. I will write something like this: minus L plus L, or minus infinity plus infinity. Choices. Okay. Minus infinity or plus infinity. Then series sigma an also oscillates finitely or infinitely according to the limit value. These are the properties of the behavior of a series. Any doubts? So always remember the series behavior. Series behavior means convergent series, divergent series, oscillate series depends on what? The sequence of nth partial sums. If the sequence of nth partial sum is convergent, series converge. If it diverges, then series diverge. If the sequence is oscillates, then series also oscillates. Okay. To understand this concept, let me tell you one simple example. Examine the convergence of the series. Examine the convergence of the series. Simple one. What is that? 1 plus 2 plus 3 plus and so on. Okay. Now solution. Let sigma an, my series is 1 plus 2 plus 3 and so on, right? And what is this then? What is Sn? Sn means sequence of nth partial sum, sum of first n terms in sigma an. So 1 plus 2 plus 3 up to plus n. You know what is this? This is nothing but n into n plus 1 by 2. This is my Sn. Right now, if I apply limit for this Sn, limit of this Sn is definitely what? Limit n into n plus 1 by 2. This is definitely what? Plus infinity, isn't it? Therefore, what is the meaning? This sequence of partial sums, you must write like this: sequence of partial sum is divergent. That implies what is a series also? Sigma an also diverges. Now the point is here: is it possible to find Sn for every series? This is a doubt. For example, one series is given like this: sigma an equal to 1 plus 2 square plus 5 by 10 plus some 4 square or 400 plus some one can say 5 square, like this. Is it possible? What is Sn? Not possible, right? Now here I consider one simple problem: 1 plus 2 plus 3, or this may be 1 square plus 2 square. That means what? If I know the formula to find the sum of the first n terms, then whatever the definitions I told, those are valid. When a series is having a complicated term and it is not possible, to find sum of first n terms, Then what? Then what? How to decide whether the given series is convergent, divergent, or oscillates? Okay. Any doubts? Now, just 5 minutes for doubts session.
Sir, what is the difference between sequence of nth partial sums and series, sir?
Sequence of nth partial sum.
Is there any difference between sequence of nth partial terms and series, sir?
Right, yeah. Sequence of nth partial sum means if we consider one series, for example, sigma an equal to some series, you take 1 plus 1 by 2 plus 1 by 3 and so on. This is nth term and so on, right? Okay. Up
Yes,
to
sir.
here, first n terms. Remember, only first n terms. This is my Sn. This is my Sn. Not alternate terms or zigzag terms. Sn stands for what? Sum of the first n terms. One can say this is 1 plus 1 by 2 plus and so on 1 by n. You can say finite series, right?
Yes,
But the
sir.
series is infinite. Series is infinite, and the sequence of nth partial sum is finite series, one can say. Clear? And remember, only first n terms. We have to select only first n terms and take the sum. That is called Sn.
Okay, sir. Thank you.
Any more? Any more doubts? And firstly, give me your attendance. Is this clear? Class is clear now? All of you? Any more doubts or any clarifications you need? Shall I decrease my speed?
No. No.
Is it audible and is it understandable?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir.
Okay. If it is offline class, it's been very good actually. Anyway, online
Yes,
class
sir.
only. Yeah, please give your attendance. Today date.
14.
ఈ
14.
ఆన్లైన్ చేయబట్టి డేట్ కూడా మర్చిపోతున్నాం. 14.
14.
14, sir.
Okay. Roll number 1. 1,
Present, sir. Present,
2,
sir.
2,
Present, sir. Present,
3,
sir.
3
4,
present.
Present, sir.
4,
Present, sir.
5.
Present, sir.
మీరే అటెండెన్స్ చెప్పండి, వేరే వాళ్ళకి చెప్పొద్దు. 6,
Present, sir.
7,
Present, sir.
8, 8,
Present, sir.
Rajesh,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.